drones are able to provide real-time information from above the ground, and that aids in decision-making about what needs to happen next, where suppression efforts might be needed most urgently, who needs to evacuate, and so on.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello, everyone. This is Randy Goers, and welcome to the Drone Radio Show podcast, episode 362. Can drones provide actionable insight into how wildfires spread? For that question, we head to Columbus, Ohio, to speak with Dr. Mrinal Kumar. Dr. Kumar is an associate professor in the Department of Mechanical and Aerospace Engineering, where he founded the Laboratory for Autonomy and Data-Driven in Complex Systems. Under Mrinal's direction, researchers are using autonomous drones to help prevent and mitigate wildfires. As witnessed by the ongoing blazes across the U.S., wildfires are difficult to predict and fight. Flames can travel up to 14 miles per hour in dry grass and spread in unexpected directions. The lab received a $1.4 million grant from the National Science Foundation to develop an aerial robotic system. The project is called the Integration of Autonomous UAS in Wildland Fire Management, and it will develop real-time situational awareness using drones to monitor the intensity and spread of wildfires. The result should help firefighting experts understand how topographic, atmospheric, and forest fuel factors influence fire intensity and rate of spread through real-time fire behavior models. Mrinal's team will shuttle the Ohio Department of Natural Resources into the southern state forests of Ohio, led by Greg Guess of the Division of Forestry. Prescribed burns are typically conducted late in the fall or early spring, where the fuel and weather conditions are conducive to a controlled burn. The drones will undergo rigorous testing and validation, leading up to fully autonomous mission design and deployment in these prescribed burns and eventually wildfires. Mrinal received a PhD in 2009 from Texas A&M University and a bachelor's degree in 2004 from the Indian Institute of Technology in Kanpur, both in aerospace engineering. During 2010 to 2016, he served as an assistant professor of mechanical and aerospace engineering at the University of Florida. In 2016, Dr. Kumar's group moved to The Ohio State University. In this edition of the Drone Radio Show, Dr. Kumar talks about the National Science Foundation grant and the university's research into drones and wildfires. But before we hear from Mrinal, I want to thank those of you who are supporting my funding campaign. Whether it's $1, $100, or much more, you can help defray the cost of production and keep the podcast going and growing. Go to droneradioshow.com/donate. And by the way, if you have a great story on the use of drones that you'd like to share in a podcast, contact me at randy@droneradioshow.com. So let's learn how drones can be used to decode how wildfires spread with Dr. Mrinal Kumar of The Ohio State University. Let's pick up the interview where I asked Mrinal to introduce himself.
My name is Mrinal Kumar, and I'm an associate professor of mechanical and aerospace engineering at The Ohio State University. And I've been in this role for about 6 years.
What type of research into UAS has been done prior at the university, and how does the current project fit into that research?
This project is actually a continuation of a significant amount of work we have done generally in the area of what is called uncertainty quantification. And that area of work looks at how autonomous platforms, generally speaking, not just drones, but that it could be ground vehicles or platforms in the air, how they would conduct decision-making and planning and execution of missions in unstructured uncertainty. So this project that we got from NSF was building on that work we did early on, looking at various aspects of mission planning and execution in hazardous, unstructured, uncertain environments.
So when you talk about decision making in unstructured environments, what does that mean?
Yeah, so that's part of the complexity of a project like this, right? Because the sense in which we talk about an environment being unstructured is somewhat loosely defined. And a lot of research is actually going into that area as well as to what exactly we mean when we say unstructured. So at least in layman terms, if you want to think about how such a problem would be set up, first of all, there is no map, right? Even if there is, it is broken, probably because of the hazard that has been playing out in that area. So that's the first loss of structure in the environment, where we cannot rely on the existence of a map. And even if there is a map, say, maybe in a flooded region, some areas may not be accessible, and we do not necessarily know which of those areas are not accessible anymore. So that is one way in which we mean loss of structure. There are several other elements that contribute to the unstructuredness of uncertainty in an environment. Typically, agents. So if you think about how agents perform themselves, a lot of algorithms may be based on models of how they understand the environment works. So in a hazardous environment or in a disaster situation, those models are typically not very well known. So they are either very poor or they're just, generally speaking, inadequate. So the absence of models and therefore, not enough reliance on model-based decision-making also contributes to unstructuredness. There are also, of course, we have eyes on the environment, different types of sensors that may be on board. And just because of the harsh conditions under which these platforms are performing, oftentimes sensors can disagree with each other, not necessarily because they are of poor quality, but just the way they interact with an environment which is just inherently super harsh. There can be anomalies in sensing, and that throws you off, because if you are the decision maker that relies on sensors and you receive conflicting information from two different sources, you have to somehow resolve that conflict before you can make an informed decision. So, there are many different aspects that make an environment unstructured. And we look at one of these pieces at a time. And of course, when it comes to actually flying, you have to put all these elements together to see if you can actually do it in real life.
So in the case of a disaster that is unfolding, like a wildfire, humans are able to survey the situation and develop a range of responses. Is that what you're trying to evaluate with UAS technology? Its ability to make those kinds of decisions?
Absolutely. So there are many different ways in which unmanned platforms can be used in disaster response. And our focus is not necessarily on the response aspect itself. It's more in the assistance with the response. So you may have larger drones that may actually be dropping fire retardants in an evolving wildfire. That's not us. That would be much larger aircraft. And actually, NASA has several studies undergoing where they're trying to evaluate the use of larger platforms for those purposes. Our work is more using smaller drones that provide situational awareness. And the drones, of course, are able to exploit the third dimension, as opposed to people being on the ground and having only a certain amount of ability to observe what's going on the ground. And of course, there are other sources of information as well, like satellite imagery and so on. But drones are able to provide real-time information from above the ground, and that aids in decision making about what needs to happen next, where suppression efforts might be needed most urgently, who needs to evacuate, and so on. So our domain of work is in that area with smaller drones that are more agile. And in terms of decision making, as the drones go about carrying out these missions, there are several decisions that they need to make. And ideally, we would like for them to make those decisions with human outside the loop, not having to be guided the whole time, while receiving information from sensors that may not be functioning properly, while trying to understand what all the sensor data means. Even if the sensors are returning great information, that doesn't necessarily mean that it gets translated to useful information, right? So if you show a 5-year-old an infrared image, and if generally speaking the 5-year-old knows that red means hot, they will be easily able to tell you where most likely the fire is and where it's not as hot, right? But that is not such an easy problem to solve when a computer has to do it. Even though it might sound absurd, it's just the way learning algorithms work. They're not necessarily able to distinguish between things that may be obvious to humans. They are also not able to necessarily connect pieces of information. So like you mentioned, while you are looking at one thing, but your body of knowledge tells you that, hey, there's something else that may be a red flag. That's not such an obvious thing for an unmanned platform or a computer to accomplish. So those would be objectives for us as well. But to be honest, those would be much further down the line. We are trying to accomplish much more simple tasks right now for the drone to be able to make their own decisions, decide for themselves that here's where I am right now. And as soon as my job here is done, this is where I need to go next, without the human telling it.
The Ohio State University received a grant from the National Science Foundation for this project. What's the objective and who's involved from the university?
So the grant has come to my department. I am the PI on the grant, which is the principal investigator. And then I have co-PIs in the Department of Natural Resources at OSU and also co-PIs at Syracuse University. So this is a multi-university grant with my department leading the project. So there are several different aspects of autonomy in unstructured uncertainty that we are trying to address with this project. So there is this piece of how would autonomous flight platforms design and execute missions in unstructured uncertainty and in hazardous environments. So that's the basic foundational research that needs to go into the science of autonomy. And that is being led by my group and a group out of the Syracuse University in their mechanical and aerospace engineering department. Then there is the context, right? So autonomy in this case needs to be carried out or be functional in a wildfire environment. And that is where the Department of Natural Resources is playing a role, because they have the experts who know about wildfires, about prescribed burns, about how wildfires affect ecology, and what they would like to learn more about modeling wildfires. So the partnership here is inherently synergistic because we are providing the technology and we are advancing the technology, and the Natural Resources Department is providing the context for that technology to be useful.
What is the scope of work for the project?
Work like this requires advancements in essentially all three areas of research. You have a ton of theoretical work that needs to be done to design and develop algorithms that would be concerned with things like guidance, navigation, and control. There is a lot of experimental work that needs to be done where these algorithms need to be put on flight platforms, and then you test, conduct rigorous flight testing, slowly building up, adding capabilities. You have work to do on sensors that would also go into experimental work. And there is also work required in the computational domain. There are a ton of learning algorithms on the platform that process a large amount of data, and that processing needs to happen fairly rapidly. So the algorithms that you develop doing your theoretical research needs to be made computationally efficient and then placed on the experimental platform. So the work plan addresses all these three different aspects of designing and executing missions. Now, if you break down a mission in an environment which is hazardous, there are multiple elements that we need to look at. There are elements that relate to the environment itself. So we have students and postdoctoral researchers and faculty members who in the team who are working on modeling of the environment, modeling of improving the models of wildfire evolution. We have work that needs to be done on quantifying the uncertainty in these models and then forecasting that uncertainty so that we can make predictions of how the wildfire will grow. We need work in the area of sensing. So what kind of modalities of sensing do we need? The obvious ones, of course, being we would like good online temperature profiles on the ground. We would need vision-based sensing, so looking at essentially pictures of what's happening on the ground. Keep in mind, most of the times, all you see is smoke. But how do you interpret that, and how do you filter out that to get good information? We also have high-quality infrared sensing. So how do these elements integrate with the platform? So that's one other line of work. Now, I talked a lot about data translating to information. So that process is called information fusion. So we have the work plan includes foundational work on information fusion from multiple sensors. How do you combine different modalities of information from different contexts to provide meaningful information about the underlying process? So there's work that needs to be done there. Now, once that information is available, that needs to be converted to situational awareness, meaning exactly where are the contours of heat, maybe at flight level, that the drone needs to avoid to get to its desired destination, right? So that situational awareness needs to be extracted from the information fusion piece. That's another part of the work. Once you have situational awareness of the environment, that serves as an input to the path planning algorithms, meaning I know how I move, I being the drone, and I have decided that I need to get here. And from the situational awareness piece, I have this layout of obstacles currently in the environment. The obstacles are not tangible in this case. They are essentially areas that are super hot that it needs to avoid on its way to the destination. So we need work in the path planning areas. How does the drone autonomously come up with its trajectory to get to its destination? Then, in order to execute that plan, you need navigation and control algorithms on the platform that process disturbances that the drones is experiencing, mainly from the wind conditions. It could be required to detect and avoid other obstacles that it did not plan for. Like if it's flying low, it needs to avoid branches, right? And so on. So the navigation and control algorithms, we are working on those as well, that will execute the plan. And then all of this, we have to integrate this so that we have a functioning system as a whole, right? These are different pieces of the mission. So we have to worry about, do we have robust communications in place? Are the sensors providing information as needed, or there is lag or gaps in sensing information, and so on? So the work plan is not necessarily a list of bullet items, but it's kind of a web that connects each of these pieces together and constitutes the mission as a whole. And we have experts in each of these areas that are working simultaneously. We meet on a regular basis and keep each other going, right? So make sure that things are moving forward along all fronts, if that makes sense.
Is the ultimate hope to be able to have a system that can look at a wildfire and provide a clear picture of the dynamics that are occurring in real time?
Yes, exactly. That's what we would hope, that after a few years of this work, we will have real-time information available for folks on the ground to use. At that point, the drones would be operationally relevant. And then, of course, if you combine that with the larger aircraft, if available for retarding the growth of fire, those aircraft will also receive information from these smaller drones. So yes, that's exactly right.
Is it possible that by understanding how wildfires evolve, that the models can also add some measure of predictability to aid decision makers as to where a fire might go or how best to approach it?
A good analogy here is if you look at how we forecast hurricanes, right? There are much better models for forecasting hurricanes than there are for forecasting wildfires. But essentially, the process is the same. We have models that will give you a pretty good view of what's going to happen next over a time window of interest. But then we don't only rely on models, because we do have sensing capabilities, right? The satellites return us excellent imagery that you can combine with the output of the model. So you have these physics-based output, which is the model, and then you have the sensor-based information, which is coming from satellites for hurricanes. And then you combine those two sources of information to get your best estimate of where you think this thing is going to go next. The process remains exactly the same here. So the drones will provide real-time sensor information, and if they are successful, they will be providing information from places that are the most relevant, where the rate of fire propagation may be the highest, or the intensity of fire may be the highest, or where the least amount of information may be known. So they will go there intentionally and get information from there. But at the end of the day, the drones will provide sensor data. Then we have these models on the ground, which will also be providing predictive intelligence. Those two sources of information will be combined by computers on the ground. So you can imagine sort of a mission control where we have ground computers that are running these models and at the same time processing the data that is being returned by the drones to come up with a composite image, an optimal image of what the wildfire looks like and where it's going next with the highest degree of confidence.
Has the project already started?
We had a kickoff meeting in October, which was before the start date of the grant. The grant officially began in January.
And how long is the term of the grant?
So this is going to be a 4-year project. We expect that depending on how well we are able to accomplish our goals, we are going to transition this into a more applied grant towards the end, where we invest more effort into building systems based on everything that we've learned during the next 4 years.
And as far as the drones, are you going to be using the typical commercially available drones, or are you planning to develop something special?
We do have commercial drones, mostly DJI drones, but we fly them as backup because the kind of things we're trying to accomplish here, it is very difficult to retrofit those things to make them behave exactly the way we want them to, right? So we build our drones from scratch. Well, not exactly scratch. We still use chassis that DJI builds, known as the flame wheel platforms. We use that as a starting point, and then we mount all our subsystems are our own, including the guidance, navigation, and control that I talked about, the detect and avoid sensing of the environment itself. So our cameras, temperature sensors, all those equipment are installed by us onto the chassis to build our own platform.
Is there anything about the project that we missed that we should talk about?
We talked mainly about research and its potential impact on operation. But this is an NSF grant, and every NSF grant has a big component of education and outreach. And that is something that is also a very big part of this project. The overall research objective is to integrate unmanned platforms with the wildfire operation and essentially, play a role in taking humans out of danger from these environments. But the educational goal for us is, this is inherently a cross-disciplinary project. And so we are interested in imparting that cross-disciplinary knowledge to the next generation of folks who are going to enter the workforce and create excitement about autonomous robotics. Our special emphasis is on accentuating the right context for autonomous robotics. I said earlier, our idea is to take humans out of danger. So how can robots be better at decision-making that would achieve objectives like that? Right. So we want to talk about that in the classroom. We want to talk about that in professional development programs. And we have a ton of public outreach material that will be developed during the next 4 years to bring awareness to topics like these. So we have already started talking to kids at all levels. We make visits to local high schools. We talk to kids there and we encourage them to come to our labs and look at the stuff that we're building. And a lot of the times we get students who work with us over the summer on projects of varying degrees of complexity, depending on their interests. And also, one of our goals is to build partnerships, identify the stakeholders who would benefit from stuff like this. in the grant, we have a direct collaboration with the Ohio Department of Natural Resources in the Division of Forestry. So we are working directly with folks who are engaged in the management of wildlands in the state of Ohio. We want to build on that and extend that to DNRs in other states. And ultimately, the goal would be to have this project grow and build sort of a consortium of multiple universities that bring different but complementary skills to the table and form a center where a lot of these different types of projects can come together and contribute to things like autonomy, flight platforms, disaster response, and so on.
As a research grant, what are some of the unique educational opportunities that you plan to pursue?
One of the sub-projects I'm trying to drive with this is to get high school kids from local schools to run their own podcast on the impact of wildfire, and especially the impact of wildfire in the eastern United States, which is much less talked about than what's going on in the West, for good reason. But there are indicators that tell us that in the eastern United States as well, wildfires are going to become a problem very soon. They are already growing in intensity, and they have always been more in number in the eastern United States, but they are not talked about as much because they are usually much smaller and less intense. But that has been trending upward. So we are trying to recruit kids to develop their own podcast series to talk about this and try and stay ahead of the problem. And we have a collaboration going with NPR to host the podcast series. That is something we're trying to get accomplished this and next summer.
And for my final question, Mrinal, what message would you like to leave regarding the future of drones in supporting decision-making?
That's a very important question, and something that not just researchers, but the general public should think about. For me, the use of drones and all robotics is all about context. And over the past few years, we have had, the advent of autonomous systems, whether or not they are truly autonomous or not, that we do not necessarily understand, but they are growing super rapidly and taking over various aspects of our life without us necessarily understanding the true impact of these platforms and how well they are able to conduct their own decision making. So I guess the message here is due diligence is important before we declare these systems autonomous and bestow on them the ability to make their own decisions. I don't think they can do that yet, and there is a lot of work that is needed before they can get to that point, especially in an environment which may not be structured. So yeah, it's about not trying to rush into it and making sure we have things figured out before we start deploying these things, because it doesn't take much for the results to, sort of not be what you expect, but, even beyond that, they can have a detrimental effect ultimately on what we're trying to achieve.
That's it for episode 362 of the Drone Radio Show. I hope you enjoyed hearing from Dr. Mrinal Kumar of The Ohio State University. I want to thank Mrinal for taking the time to speak with me. If you want to learn more about the Laboratory for Autonomy in Data-Driven and Complex Systems at The Ohio State University, or want to connect with Mrinal, check out the website at mae.osu.edu/LADDCS. If you like the Drone Radio Show, please consider supporting the podcast with a small donation. The content is always free, but for as little as $1, you can help defray the cost of production. To donate, go to droneradioshow.com/donate. And thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Gores.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.